Thank you, Brian. That was really kind. I want to also thank Lucy for putting my narrative together and all these great pictures and things which are hopefully, which add, I think, a lot to what I'll be talking about, which is essentially the overview on the present COVID-19 vaccine and the one that will be available to our staff. There are just two actually that are presently available, and one or the other will be available, or both will be available to staff as the rollout takes place. So shall we start, Lucy? There we go. So we'll go back down to basics. And what is a vaccine? It's just a substance that's used to produce antibodies, and antibodies are proteins which are made by blood cells, and they provide immunity against several diseases, one of which is COVID. Go next. There are about 40 plus vaccines that are in the pipeline right now for COVID-19. The two that have reached that have been approved by the FDA for emergency use are very similar, and we'll be talking about them in a little more detail. And both vaccines are a genetic type, and they use mRNA. There's several other kinds of interventions that can be used for vaccines, but these two are very, it's new technology that has been around for a long time. And it's also, the two are pretty close in not only how they are effective, but also their side effects and how they compare from one to another. Next, please. Thank you, Lucy. And okay. So to explain an mRNA vaccine, the mRNA is really a small strand of genetic material that will provide the instructions for the production of proteins. The mRNA vaccines are new but not unknown. So these have been used in the past in treatment of some cancers. There's also been some study of the Mediterranean SARS disorder some years ago, and mRNA vaccines were studied at that time, although I don't believe that that ever came into actually actively used. The mRNA vaccines do not carry live virus, and so there is no risk of causing the disease in anybody who is vaccinated. And that's very important because a lot of people are concerned about getting the injections and then getting COVID. Yesterday, several of us, or many of you too, probably listened to the afternoon presentation, and Dr. Talbot, who works for, this is, I think, the deputy, what did you call her, Brian? Epidermology. I like the way you pronounced it, Barrett. She's, I think, the deputy epidemiologist for the state. And she was saying that there are 27 proteins that make up a virus cell, or the virus, of which the mRNA vaccines only have one protein. And it is only a fragment of the proteins that make up the spikes. So everything is related to the spikes. The mRNA vaccines never enter the nucleus. People are often concerned that it will get into the nucleus of the cell and therefore affect the person's DNA, and that is not a possibility. Next, okay. So this is a great slide that Lucy found. I think it's helpful to sort of see the sequence. So the coronavirus has spikes, and the spikes have been identified as a good place to attempt to get an antibody to inactivate or kill the virus. So what the scientists have done is they have sequenced the protein from the spikes, and then they have produced that in the lab, and then they coat it with lipids. And they do that because the mRNA is very fragile. And if it was just injected as the piece of genetic material, it would be metabolized very quickly and deactivated by enzymes that are simply outside the cell and in the muscles. So the lipid allows it to be taken up by the cell. And once it's inside the cell, the RNA or the mRNA can then begin to blueprint some of the spike protein. And again, the spike protein that is being made is a fragment of the proteins from the virus. And about some studies say it's about a third of a spike protein. And again, I just want to reiterate, it is very safe. It is not something that will make the virus. It is just making the virus hopefully susceptible to destruction by immune cells that are produced. So once the cells receive that information, they make lots and lots and lots of copies here. It says here millions of copies of spike protein. And then those proteins are deposited on the outside of the cells. Now, these cells that we're talking about are actually muscle cells. The body's defense mechanism, basically the white blood cells, identify those as fragments of unknown source, which are felt by the white cells, if the white cells feel anything, I guess, need to be obliterated from the body. And so they will do that. And in the process, they will also build up more antibodies so that the body begins to provide its own defense against a protein that is in the virus that will destroy the virus, but only one protein is used for the vaccine. Next. Okay. So we have two vaccines. First was authorized as Pfizer several weeks ago. It requires 2 doses, and it's given, and those doses are given 3 weeks apart. And just, here we go. The problem with this one, it's not a problem, but it's just it's a management issue, is that it has to be stored at very low temperatures, minus 94 Fahrenheit or minus 70 Celsius, which also makes it difficult to move and equipment that's necessary to use it, move it, and keep it safe for use is more complicated than for some other interventions. Vaccine is 95% effective after the second dose, and it is an injection into the deltoid muscle in the arm. Next one, please. Moderna is, I just have to get my own little cell here. Moderna, which has more recently been authorized for emergency use, also requires 2 doses, but these should be separated by 28 days. It stores in a refrigerator at about -4 degrees or -2 centigrade. And its efficiency is 94.5%. So it is more easily transported and supported by the refrigeration and those kind of things that are readily available. It's also a muscle injection, and essentially they're very similar. The benefits of mRNA vaccines. First of all, there is no they use non-infective materials which are produced in a laboratory. They are fragments of proteins that are the result. Their use, and I know I'm being redundant, but their use is, their infectivity is nil. They can be produced really quickly and consistently because the mRNA strands are taken from a template from DNA, so that the DNA for the spikes can be replicated through the mRNA, and they can be consistently replicated. The process has been standardized. It has a fairly short manufacturing time to produce the vaccine. And other vaccines require a variety of different modalities. For example, some have to, well, if the flu is grown in eggs. So this has, and it takes a lot longer to get a flu vaccine than it does to get the mRNA vaccines. There are no preservatives used whatsoever, and they are equally effective in all age groups who can receive the vaccine. So, what are the benefits of getting vaccinated? Vaccination will help help you to avoid getting COVID-19. It may keep you from getting severe COVID-19 symptoms if you should be infected after the vaccination. When I say if you do get infected after the vaccination, it's not 100%. Some people will may get COVID afterwards, but the result is much less devastating than the full disease. Very much like flu. You can get the flu shot, and you might get the flu at some point, but probably not anywhere near as devastating as it might be without the benefit of a vaccination. The vaccinations will also protect people around you, and it is a very significant tool along with all the CDC recommendations that we already have: washing hands, wearing masks, social distancing. All of this together is going to be necessary to stop the epidemic. So essentially, right now, we don't have any vaccines on the market or available, even by emergency, for children. The Pfizer vaccine is for anyone 16 and older. Moderna is anyone 18 and older, and that basically is because the population that was used in order to investigate their vaccines included those age groups and older and not younger. My understanding is that there's some of the other vaccines that are being evaluated may be appropriate for children, but right now we don't have anything for children. Next. So the important part of this slide is really that there are no absolute prohibitions, other than if somebody is allergic to any of the components in any of the vaccines. So even individuals who have allergies, who are prone to allergies of all sorts, if they're not specifically allergic to any of the components of the vaccines, they can still get the vaccine. With the caveat that the observation time, which is now used after one gets the vaccine, is 15 minutes for most. Observation time for someone who might have or might be prone to allergies is 30 minutes. A lot of questions have been brought up and concerns regarding pregnant women and lactating women. There were no, this is a cohort that were not included in any of the studies. However, the general consensus is that because there is no active virus, no ability for the vaccines to actually infect a woman or her fetus, that these vaccines can be utilized safely by women who are pregnant or are lactating. The recommendation for these individuals is first to discuss the vaccination with their OB or pediatricians, depending, prior to receiving the injection. So, side effects. Everything has side effects. Water probably has side effects if you really think about it. The COVID vaccines are very safe, as I said. Most injection side effects are transient if they occur. They may occur for the onset, probably is somewhere around within the first 24 hours after getting the injection. And it includes fatigue, headache, aches and pains, fever, and some lesser side effects. I've got a rather exhaustive list if anybody wants to ask me later. The side effects usually resolve in a couple of days. And some people have them worse than others, but they're not devastatingly bad. The second injection tends to cause a bit more side effects than the first, but again, this is a very transient kind of discomfort. Also, the injection site redness or swelling is often also identified, and that will resolve without treatment. I think the concern again, and what Dr. Talbert was saying yesterday, is that when you get these symptoms, that the vaccine is working, and you are experiencing its on-the-job activity, so to speak. The side effects, as I said, will dissipate. The only issue that some people have concerns about is if they get these symptoms, which are often reminiscent of COVID, how will they tell the difference? And there's a variety of different interventions and concerns and ways of looking at that. But the majority of people are not going to have COVID or be allergic or be infected with the virus at the same time they're getting the injection. So the majority of people are experiencing side effects, not effects of the disorder. Next.